It is my absolute pleasure to introduce our speaker today, Dr. Shoji Tsuji, who is a professor of neurology and the director of the Medical Genome Center at the University of Tokyo Hospital. He received his MD and PhD from the University of Tokyo, followed by his residency in neurology at Jichi Medical School. Dr. Tsuji served as a professor of neurology and the director of the Brain Research Institute at Niigata University, and then moved to the University of Tokyo in 2002. For over 30 years, he has been a leader in neurogenetics and has made several important scientific discoveries. This includes research breakthroughs on Dentatorubral-Pallidoluysian Atrophy, DRPLA, Neuronal Intranuclear Inclusion Disease, NIID, Parkinson's disease, and of course, Multiple Systems Atrophy, which he'll be chatting with us about today. And with that, Dr. Tsuji, the floor is yours.
Thank you for kind introduction, Celeste. Here's my disclosure. So in my talk, I'll first describe the outline of multiple system atrophy, and then I'll show you our recent activities of Japan MSA registry. And then I'll move on to the elucidation of molecular basis of MSA. I'll show you the decreased coenzyme Q10 is involved in MSA. And in the last part of my talk, this is the most important part of my talk, which is the clinical trials of supplementation of a high dose of ubiquinol. Ubiquinol is a reduced form of coenzyme Q10. And I will show you the excellent results of phase 1 and phase 2 clinical trials conducted in Japan for MSA patients. So let me describe what MSA is. As you know, MSA is characterized by various combinations of cerebellar ataxia, Parkinsonism, and autonomic dysfunctions, with a mean age at onset of 57 years. Two subtypes, MSA-C, presenting with predominant cerebellar ataxia, and MSA-P, presenting with predominant Parkinsonism, have been established. Accumulation of alpha-synuclein, mainly in oligodendroglial cells, has been identified as a pathological hallmark for MSA. But etiologies of MSA, including the mechanisms for alpha-synuclein accumulation, still remain to be elucidated. And as shown in the diagnostic criteria of MSA, familial occurrence of MSA is rarely observed. So it is essentially the sporadic disease. In Japan, it is estimated to be that there are 12,000 patients with MSA in Japan. So it's not a rare disease. This slide shows the natural history of MSA, as shown in the panel to the left. About half of the patients with MSA became unable to stand without support in 5 years after the onset of MSA. So among the diseases of cerebellar ataxia, MSA is a progressive and devastating disease, as shown in this slide, compared to other types of cerebellar ataxia. Unified Multiple System Atrophy Rating Scale, UMSARS, was developed by Professor Gregor Wenning, and this scale has been frequently used for evaluation of the severity of MSA. UMSARS Part 1 evaluate the historical review of MSA, and Part 2 evaluate the motor functions of MSA patients. And Part 1 scores consist of 12 items, and Part 2 consists of 14 scores. And scores are given from 0 to 4. So the sum of these scores are used for evaluating the disease severity of MSA. So this is the time course of UMSARS Part 1 score. So on the average, patients have the about 15 scores at the onset and progresses to more than 30 in 9 to 10 years. And UMSA-RS Part 2, evaluating motor score, motor function, also showed a similar pattern, starting from around 15 to 30, more than 30 in 10 years. This slide simply shows the natural course of MSA. So MSA shows the slowly progressive course as shown in this slide. And currently available therapy is symptomatic therapy. Now, although symptomatic therapy is effective for the symptoms, but this therapy cannot modify the natural course of MSA. So what is really needed, desired, is the disease-modifying therapy, which can suppress the progression of the disease. So to develop disease-modifying therapy for MSA, we need to elucidate the disease mechanisms underlying MSA. Since MSA is a basically sporadic disease without familial occurrence, it is very difficult to elucidate the disease mechanisms. So how we can elucidate the molecular mechanisms of sporadic MSA? The major question comes as, are there any genetic factors present in MSA? And my answer is yes. Although the frequency is extremely rare, there are multiplex MSA families. And number two, there seems to be a difference in relative frequencies in MSA subtypes among different ethnic populations. So MSA-C is more common in Japanese, while MSA-P seems to be more common in Caucasian populations. So these observations suggest that some genetic components are involved in development of MSA. So if genetic factors are involved in MSA, how can we identify them? So this slide shows the regional differences of the relative frequencies of MSA-C and MSA-P. In Japan, the majority of the patients have the MSA-C phenotypes. In contrast, in Europe or North American populations, MSA-P is more frequent than MSA-C. So these observations suggest there may be some genetic backgrounds in the differences, in regional differences in the relative frequencies of MSA-C and MSA-P. So I believe there are multiple genes are involved in MSA as shown in this slide, and combinations of genes may vary among patients with MSA, and we should develop treatment for each gene or each allele, and combination of these treatments will be the final goal of the development of therapy for MSA. So how can we proceed to elucidate molecular basis of neurological diseases? So we need to consider different approaches, strategies for familial cases of MSA and sporadic cases of MSA. For multiplex families, we have demonstrated usefulness of multiplex families to identify disease-relevant alleles with large effect sizes. I will show you this point later. So we made every effort to identify multiplex families through nationwide investigation in Japan. And furthermore, the multiplex families have been reported from Europe and the States. For sporadic cases, thanks to the advancement in technologies for genome analysis, we are now able to obtain the entire genome sequence from individual people. Genome sequence studies repeat numerous candidate alleles with high odds ratios, which is quite promising. However, to unequivocally confirm these relevant alleles, we need large sample sizes to validate the results. Therefore, we established Japan MSA registry to accumulate clinical information and bioresource from MSA patients in Japan. Also, we are trying to establish international collaboration to accelerate the MSA research from the viewpoint of genome analysis. Let me briefly show you our activities of Japan registry. We established MSA registry in 2016, 7 years ago, and the objective of MSA registry, number one, to facilitate recruitment of MSA patients to clinical trials. In the first clinical trial, MSA patients will be stratified based on the CoQ2 genotypes of MSA. So the information of the CoQ2 genotypes of the MSA patients registered in this registry has been shown to be quite useful, helpful for conducting the phase 2 clinical trial. Number two objective is to establish natural history of MSA. We are getting the UMSRS Part 1 score every 6 months based on telephone interview with the MSA patients and families. And also we are obtaining the Part 2 score every 1 year, examined by a neurologist. And objective number three is to collect bioresource. The bioresource, including genomic DNA and plasma, are banked at Rare Disease Bank of National Institute of Biomedical Innovation, Health and Nutrition, and which are made available to research communities upon request. So if the researchers are interested in analyzing the bioresource in this bank, the researchers are free to ask for the bioresource to this institute. And 30 institutions in Japan participate in the MSA registry as shown in this slide, including University of Tokyo. This complicated slide shows the concept of the MSA registry. The UMSA-RS Part 1 score was obtained through telephone interview every 6 months by nurses. And we asked the annual visit to a neurologist to obtain UMSA-RS Part 2 score by neurologists. And all the informations are collected to the contract research organization CRO. And bioresource is collected at the University of Tokyo as well as at Rare Disease Bank at National Institute of Biomedical Innovation. This is made available to researchers. And at the University of Tokyo, CoQ2 genotypes are analyzed, and information on CoQ2 genotypes are also collected at the CRO and then stored at the cloud database. And this data will be made available to clinical trials in the future, including the clinical phase 2 clinical trial we conducted. And up to now, close to 600 MSA patients are registered in the Japan MSA registry. So I think this is probably the largest MSA registry in the world. Let me move on to the third part of my talk. That is molecular basis of MSA. So to elucidate risk alleles with large effect sizes, application of next generation sequencers should accelerate discoveries of risk alleles or risk genes with large effect sizes, since we can virtually obtain all the genome sequences. However, this is not easy. Ideally, the data-driven approach or unbiased approach should clarify, elucidate genetic components involved in MSA. But to accomplish this, large sample sizes are required to accomplish sufficient detection power. Probably we will need more than 10,000 MSA patients to accomplish this. So for this purpose, the international collaboration is absolutely required. The second approach is genetics-based approach. So presence of risk alleles with large sizes often leads to familial clustering of the disease. So studies focusing on multiplex families are expected to be highly effective in identifying rare risk alleles. The third approach is a hypothesis-driven approach. If we can think about candidate genes, the approach of hypothesis-driven approach is highly effective since we just test the limited number of the candidate genes. So in my talk, I'll focus on genetics-based approach. To make a long story short, we were able to identify 6 multiplex families with MSA in Japan, and we were able to identify the causative biallelic variants in 2 of the 6 families. The gene is CoQ2. I'll show you in detail later. And CoQ2 encodes an enzyme involved in biosynthesis of coenzyme Q10. And mutations in CoQ2 gene is expected to result in reduced or decreased synthesis of coenzyme Q10. And indeed, we found the dramatic decrease in CoQ10 content in cerebellum of the patients carrying the biallelic variants in CoQ2 gene. This slide shows the functions of coenzyme Q10. It's been shown that coenzyme Q10 has 2 functions. One important function is the biosynthesis of energy, ATP, in mitochondrion. So in mitochondria, CoQ10 works as a carrier of electron from complex 1 to complex 5. So reduced content of coenzyme Q10 in mitochondria is expected to result in reduced synthesis of ATP. Another function of coenzyme Q10 is its antioxidant activity. CoQ10 has a strong reducing activities. Therefore, it works as a protective agent against reactive oxygen species, including superoxide, hydroxyl radical, hydrogen peroxide, single oxygen, etc. So decreased coenzyme Q10 may lead to the oxidative stress and increased vulnerability of neuronal cells against the reactive oxygen species. We then found that CoQ2 is a susceptibility gene in sporadic MSA as well. So we found that the carrier of CoQ2 V393A variant is associated with increased risk of MSA. Japanese MSA patients carry this variant at a frequency of 9%, which is much higher than 3.3% in general Japanese populations. And given the odds ratio of 3, is a substantially high number as a risk factor. And through the international collaboration, we found that CoQ2B393A is a common risk factor in East Asian populations. The meta-analysis of 9 studies reported from Japan, China, and Taiwan showed that the odds ratio of 2.1 with the p-value of 0.0047. So this is highly significant. So this slide shows that the CoQ2B393A is a common risk factor in MSA patients in East Asian populations. But this is not the case in European or North American MSA patients. Before that, if we divide the MSA patients in MSA-C and MSA-P, we found that association of this variant, CoQ2B393A, is highly significant in patients with MSA-C. And in MSA-P patients, the association seems to be very weak. So CoQ2B393A is a strong risk factor for MSA-C. And looking at the carrier frequencies of CoQ2B393A in various populations, we found that the majority of the European descent populations do not carry this variant. But in contrast, the carrier frequency is higher in East Asian population. And interestingly, the Latino admixed American populations seem to have the higher carrier frequency of B393A. This may be derived from the history that Latino admixed American population was originated from Asia. So it is interesting to study if the MSA patients in Latino admixed American populations may have further increased carrier frequency of the B393A. So the difference of allele frequency of CoQ2B393A in the world is quite distinct, as I mentioned. And B393A is highly common in Japanese and East Asian populations, and maybe this commonly the risk factor for Latino mixed American populations as well. Moreover, in addition to CoQ2B393A, we found that other functional deleterious CoQ2 variants are also associated with increased risk of MSA, regardless of the regions. So we found these very rare CoQ2 variants, not only in Japanese, but also in North American or European MSA patients. So although the frequency is extremely rare, it may be helpful to explore for these rare variants in CoQ2, even in European or North American MSA patients. After we discovered the CoQ2 variants in MSA patients, very interesting discovery has been reported worldwide. That is, quantum Q10 is decreased in MSA patients not carrying CoQ2 variants. So quantum Q10 is decreased in serum, plasma, or in cerebellum, or in cerebrospinal fluid. So these observations indicate that coenzyme Q10 is commonly decreased in MSA patients, even if the MSA patients do not carry co-Q2 variants. So we demonstrated MSA patients with biallelic or heterozygous co-Q2 variants. And furthermore, in MSA patients not carrying co-Q2 variants, decreased coenzyme Q10 levels has been reported in plasma, serum, cerebrospinal fluid, moreover in cerebellum of autopsied brains. So decreased coenzyme Q10 levels commonly underlie MSA, not only in MSA cases with co-Q2 variants, but also in those without co-Q2 variants. These findings suggest that supplementation of coenzyme Q10 may serve as a therapeutic approach for MSA. Now, I'll show you the results of clinical trials of supplementation of high-dose ubiquinol, reduced form of coenzyme Q10 for MSA. So to summarize the background, biallelic variants in COQ2 gene have been identified in the two multiplex MSA families, and V393A variant in COQ2 have been identified to be associated with sporadic MSA cases in East Asian populations by meta-analysis. The mean carrier frequency of COQ2 V393A in East Asian general population is 3.6%, while it is virtually absent in European descent general populations. Decreased coenzyme Q10 levels in plasma, cerebrospinal fluid, and cerebellum have also been demonstrated in MSA patients not carrying COQ2 variants. Supplementation of coenzyme Q10 may be efficacious as the disease-modifying therapy for MSA patients. With this background, we conducted a phase 1 clinical trial to evaluate the safety and pharmacokinetics of high dose of ubiquinol given to healthy volunteers. This phase 1 clinical trial was indicated by the regulatory agency in Japanese government, which is equivalent to FDA in the States, because we plan to use very high dose of coenzyme Q10. Therefore, we are asked to evaluate the safety and pharmacokinetics of high doses of ubiquinol. And with the phase 1 clinical trial completed, we then conducted a phase 2 clinical trial to evaluate the safety and efficacy of high doses of ubiquinol given to MSA patients. Let me first describe the results of the clinical trial, of phase 1 trial. So this is the study design of the phase 1 clinical trial. This is the randomized placebo-controlled study, and we tried 3 doses of 900, 1200, and 1500 milligrams of ubiquinol. And we assigned the ubiquinol to 6 individuals and placebo to 2 individuals. And we observed a substantial increase in plasma ubiquinol depending on the doses of the ubiquinol. So the highest blood level was accomplished with the 1500 milligrams of ubiquinol, as shown in this slide by green color. We also found increased level of ubiquinol in cerebrospinal fluid. So the ubiquinol concentration or coenzyme Q10 concentration in CSF is dramatically increased upon administration of the coenzyme Q10. So the phase 1 study was completed in May 2016. And we observed no serious adverse events. And detailed pharmacokinetics data of CoQ10 in plasma, peripheral blood mononuclear cells, and CSF were obtained. Encouraged with the results of phase 1 clinical trial, we then moved to phase 2 clinical trial. The study design of the phase 2 clinical trial is a multi-center study to evaluate efficacy and safety of ubiquinol or CoQ10 in patients with MSA. And 13 institutions in Japan participated in this study. MSA patients who fulfilled probable or possible criteria and could independently work were enrolled. And the MSA patients were stratified based on genotypes of CoQ2. 20 patients with B393A and 100 patients without B393A are enrolled. And the MSA patients were randomly assigned to ubiquinol or placebo with a ratio of 1.1 to 1. And the primary efficacy outcome was the changes in UMSA-RS Part 2 score from baseline to week 48. Secondary efficacy outcomes include UMSA-RS Part 1 score, Bartle Index, scale for assessment and rating of ataxia scores, and 10-meter walk type. And the dose of ubiquinol was increased from 300 milligrams gradually up to 1,500 milligrams per day and continued to 48 weeks. And this is the summary of the results of the phase 2 clinical trial. And due to the pandemic of COVID-19, we experienced very difficulties in conducting the clinical trial. But thanks to the effort of the patients and participants, we are able to complete the phase 2 clinical trial as shown in the slide. And we observed significant suppression of the progression of the UMSA-RS Part 2 score at 48 weeks, as shown in this panel at the left. And we also observed the substantial decrease in the suppression of the progression of the Bartle scores at 48 weeks. So this slide shows the ubiquinol is effective to suppress the progression of the progress of MSA. And more importantly, during the observation period after 48 weeks, at the 48 weeks, the ubiquinol was stopped, but we still show the similar trend after the stop of the administration of the ubiquinol. So the UMSA-RS Part 2 score in the ubiquinol group did not deteriorate toward the observed in placebo group at 52 weeks after a 4-week washout period, so supporting the role of ubiquinol as a disease-modifying effect rather than a symptomatic effect. So supplementation of a high dose of ubiquinol is effective to suppress the progress of UMSA-RS Part 2 score by 24%, supporting the role of ubiquinol as a disease-modifying therapy for MSA. And through the discussion with the PMDA, the governmental agency equivalent to FDA in the States, we are being asked to conduct phase 3 study to confirm the efficacy of ubiquinol for MSA. So we still need to conduct another phase 3 study to confirm the efficacy of the ubiquinol for MSA. And we really wish to complete the phase 3 clinical trial as soon as possible. So thank you for your kind attention. And finally, I'd like to thank my collaborators as shown in this slide. Many researchers and other people involved in clinical trial participated in this result. Thank you for your kind attention. And I'll be happy to take questions.
Thank you so much, Dr. Tsuji. And just a reminder for folks, if you do have questions, please drop them in the Q&A window at the bottom of your screen. Unfortunately, we are unable to unmute people if you've raised your hand. So we ask that you put them in the Q&A window and then I can read them out on your behalf. And we already have some questions that have been sent in. So the first being, so you talked about the prevalence of MSA in different populations. Have you, or is there any data available on the prevalence of MSA in people of African origin?
Oh, that's a good question. I really do not know. And in Japan, we have a very interesting system of nationwide survey conducted by Japanese government. So it is easy to get the information of the prevalence of the patients. But in other areas in the world, it is not easy because I don't think the nationwide survey is conducted even in the States or Canada or in European countries. So I think the nationwide survey system is very, very important to get the sufficient information.
That gives you a better sense of prevalence rates. That's one tool to better understand prevalence.
Yes.
All right. And then our next question here. There's someone who would like to know if there's a difference between the drug that's being studied in your clinical trial, ubiquitinol, and another form of coenzyme Q10, Idebenone, which has been used in Friedreich's ataxia. Do you have any understanding of the differences between those two compounds?
Well, the Idebenone has the similar actions as coenzyme Q10 as a highly reducing activity. But we have not tried Idebenone for MSA patients. So we cannot tell the effect of Idebenone for MSA at the moment. But the coenzyme Q10 is a natural substance present in our body. So I think the supplementation of coenzyme Q10 is reasonable and should be efficacious.
Well, that was the next question that was actually come up. There was someone who was wondering if ubiquitinol is more effective than the typical coenzyme Q10 supplements that you can get over the counter. And if that's something that they might want to consider taking.
Yeah, that's a good question. The bioavailability, there are two forms of coenzyme Q10, oxidized form, which is called ubiquinone, and reduced form, which is called ubiquinol. So it's been shown that the bioavailability of a reduced form of coenzyme Q10, ubiquinol, is much higher than bioavailability of oxidized form. So it is generally suggested that the reduced form of coenzyme Q10 is more efficacious. But we used the 1500 milligrams of ubiquinol. That is extraordinarily higher than that contained in supplement. So, it is unrealistic to get such amount using the supplement. And also we need to be careful for the adverse events of high doses of ubiquinol. So it is not generally recommended to get large number of tablets or supplements.
That makes total sense. It's one of those things why you have to do clinical trials, to make sure that things are safe and you're monitored by your healthcare professional, just to make sure that things are working properly.
That's absolutely right.
And then speaking of clinical trials, we had someone in the chat who is interested, who's outside of Japan, but interested in participating in clinical trials. Can foreigners join Japanese clinical trials, or are there rules against that?
That's a good question. We can further discuss on this possibility. I think it is important to conduct the clinical trials for patients in other countries as well. And so probably, that we need to discuss with the regulatory agencies such as FDA about the design of clinical trials, also the financial support. So it would be nice if the other clinical trials are planned and conducted in the States, Canada, European countries, or Asian countries. Would be very pleased to discuss with the possibility, but we need to involve many researchers and regulatory agencies in other countries simultaneously. So I'd be happy to further discuss on this possibility.
Yeah, it's a group effort. You need people working all over the world in order to bring something like this together.
Yes.
And then there's just a quick question for NAF. Is this presentation going to be made available? Yes, a recording of this presentation is going to be posted. It's going to take us about a week just to get it up online, but that will be shared. And then we have another question. For your phase 1 study and your phase 2 study, sorry if they missed this, but the people participating in those studies, were they folks who had the variants that you described, or were they folks who had MSA diagnoses but may or may not have had those specific variants?
In the clinical trial, as I mentioned, the 20 patients with co-acute variants participated, and 100 patients without co-acute variants participated in the clinical trial. And since we had a very small number of the MSA patients with co-acute variants, 20 patients, so statistical evaluation was not easy, but we observed similar results in terms of the suppression of the progression of part 2 scores, both in MSA patients with co-acute variants and in MSA patients without co-acute variants. So we observed similar tendencies regardless of the MSA co-acute variants.
That's very interesting.
Yeah.
And then there's someone who's interested, if this information can be made public, and we understand if it's not, can you share any progress that's been made in terms of setting up the phase 3 trial that you were talking about, or any timelines of when that's going to happen?
Well, all the data I presented are published, so you can access to the e-clinical medicine sister journal of Lancet. So all data are available, and we'll be happy to share the results of the phase 3 clinical trial with you. And right now we are still discussing with PMDA about the design of the phase 3 clinical trial. So I believe we can start the phase 3 clinical trial sometime in the next year.
That's very exciting.
And it will take 1 or 2 years to complete. So please be patient.
Yes, these things take time to put together. And then there's someone who's follow-up question to that. Is that something that would require in-person participation? So they'd have to live in Japan to take part? Or is it something that potentially they could visit the country if they were interested in participating in?
Well, at the moment, we are considering the patients who are living in Japan. And as you may know, there may be the difference in the many factors among the people with different populations. So it would be required to focus on the one population to evaluate the clinical efficacy. So I think it will be probably the most important to conduct another clinical trial in the States, North America, or Europe.
So starting small and then following up with other populations later on.
So please ask your physicians, why don't you try phase 3 clinical trial in the States?
We do have a follow-up question that there's someone from the US who is interested in getting involved in MSA research. They had a question, do you have any recommendations on if they want to get involved? Are there people they should reach out to? Should they reach out to their current physician? Do you have any recommendations on how they can get involved with research where they are?
Well, as I mentioned, the most important point is the international collaboration, and we will need extremely large sample sizes to accomplish our goal. So I think it would be important to collect as many as by resource in individual countries, in the States, Canada, or European countries. And at the moment, Dr. Sonia Schultz at NIH is conducting the whole genome sequence analysis on close to 1,000 MSA patients with European descent background. So we are also collecting about 600 MSA patients in Japan, and we're conducting whole genome analysis. But as you know, the 600 or 1,000 are not probably sufficient to accomplish our goal. We may need more than 10,000 sample size. So it would be important to try to collect as many samples in individual countries, and we can perform the international collaboration.
Could you say again the name of the researcher at the NIH who is researching MSA in the United States? Sonia, what's her last name?
Sonia Schultz.
Sonia Schultz.
Sonia Schultz. Also the Dr. Ku in Colombia, and Henry Paulson may be interested in, and also many researchers at in Minnesota.
We heard earlier this week from Dr. Kuhn, who is a physician at Mayo Clinic, about some of the work they're doing for MSA patients at their center. And for other folks who are interested in joining different patient registries, I know the National Ataxia Foundation, we have a patient registry. You may want to reach out to the MSA Coalition. They are doing fantastic work in the United States. There's also the CORDS registry, which if you look it up through the National Ataxia Foundation, it's a separate organization that is a patient registry for rare diseases. So multiple ways to get involved.
Yes. Professor Kaufman in New York City is also working on the natural history of MSA.
Oh, fantastic.
Yeah.
That's great. And then I'm just being aware of the time, I'm going to scroll through for other questions. So we have a few people who've asked a similar question for they have a loved one or themselves have MSA. They currently live in North America and they have limited access to clinical studies. What kind of things could they be doing to improve their quality of life where they are currently?
Well, as I mentioned, there are many symptomatic therapy for each symptom. If you have the severe autonomic nervous system dysfunctions, there are many drugs to regulate the blood pressure, and also for Parkinsonism, there are many drugs. So please ask the physicians to treat individual symptoms you have.
That's good to know. So reach out to your healthcare provider, get in touch with the neurologist, get a referral, and they can help you manage some of the symptoms.
And also it is very important to keep the physical activities. So for example, rehabilitation or something like that should be very effective to protect the progression of the motor dysfunctions in this disease.
That's good to know. Thanks for that advice. And then we have a question from someone else who is interested in if CoQ10 or bubucanol, if anything is known about if that could be helpful for other forms of neurodegenerative disease, like spinocerebellar ataxia. Is anything known about that?
Well, the coenzyme Q10 has been tried for many neurological diseases, including Huntington disease and other diseases. But the previous clinical trials are unfortunately proved to be ineffective for other diseases. So at the moment, coenzyme Q10 is shown to be efficacious only for MSA.
Well, it's too bad for the other conditions, but I'm glad that there's been some progress for MSA.
Yeah, because as I mentioned, the coenzyme Q10 level is decreased in MSA patients. That is the theoretical background for supplementation of coenzyme Q10. So I think the coenzyme Q10 is effective for patients who have the decreased coenzyme Q10 levels in the body.
That makes a lot of sense.
Yeah.
And I'm just looking at the Q&A window, and we have gotten through all of our questions. So thank you again, Dr. Tsuji, so much for sharing your time and expertise with us. We greatly appreciate it. And thank you everyone who's on this call, who stayed with us until the end to learn a little bit more about MSA. I hope you found this valuable. And
yeah, thank you very much. I enjoyed. And please stay touching with us.
Will do. And wherever you are in the world, good morning, good afternoon, good evening. Hope you have a wonderful rest of your day. Bye, everyone.